How are you doing today?
Fine.
You guys have a nice Thanksgiving?
Yeah, we did.
Yeah, good. So you've got a couple weeks before your final, your semester final here. So what are we working on today or tonight?
Chapter 6.
Polygons, right?
What?
What's the title?
Yeah,
Is it
we're still
Polygon?
doing just similarity.
Ah, similarity, which is not polygons. Let's see, let me figure out which chapter in my book is similarity. It's chapter 8. Okay. That's actually, I've always wondered why they don't put similarity after congruency, because you can't find two subjects that are closer than congruency and similarity. Similarity is basically the three angles are the same. That's how you prove similarity.
Yep.
Obviously, if two triangles are congruent, they're also similar, but you don't have to have congruency to have similarity. In other words, if I have that triangle and that triangle, they're obviously not congruent, but as long as these angles are the same, then they are similar. And the beauty of similarity is that corresponding parts are proportional. In other words, if that is we'll call it a 3, 4, 5 triangle, and I'll make this a 6, 8, 10 triangle. Let's talk about this a little bit, because this can be a little confusing. When I am talking about similar triangles, I can make a bunch of proportional statements here. In other words, I can compare this side of 3 to this side of 6 and say 3 is to 6 as 5 is to 10 and as 4 is to 8. You with me?
Yep.
So all of those are true, but at the same time, the relationships within the triangle are also the same. In other words, I can also say 3 is to 4 as 6 is to 8. So I'm comparing that side to that side, has to be the same proportion as the corresponding side divided by that corresponding side. And any confusion that exists with similarity usually arrives from this property, is that you can not only make statements about corresponding sides between the two triangles, but you can make statements about sides within the two triangles. You see what I'm saying? In other words, I can come up with lots of proportions that are true as long as I know that two triangles are similar. Now, do you have any problems you can send me that we can do?
Just set them.
Okay. These look like they are part of the body of the email as opposed to an attached file.
Oh, I sent attachments. It's just Gmail's got a new update.
I don't have an attached file on this email.
I hit the link button. If you want me to send it again.
Send it you have an iPhone, right? Send
I have a phone, yeah.
one attachment only, the first one that you want to go over, and send it as a large image attachment. don't just put it as a body to the text of the email. Send it as an attachment, because then I can download it and I can rotate it.
The thing is, the pictures I took, they were with my iPad. You just want me to retake the pictures?
Sure. Whatever works, whatever allows you to send it as an attachment as opposed to...
Might not be good because...
Well, we'll see. But see, I can't do anything with this because it's horizontal and upside down, and I have no way to rotate them. I don't think. Let me see. Oh, excuse me. I'm sorry. I didn't notice I could download that. Hold on. We're in business here. You don't need to resend them.
Okay.
Yeah, I didn't realize that there was a download at the bottom of that thing. Is this the one you want to start on, or the other one first?
The other one, the bottom one.
Okay, let's do that.
I just send them in the opposite order in which I take them because that just seems to be
That's
the easiest
fine.
way.
I didn't notice that download button right there that allows me to download the file. Now I can rotate it. All right. And zoom. Which one do you want to start with?
So we're doing 1 and like 3 through 12.
Okay. 1 and 3 through 12. Hold on a minute. Can't quite see 1. Can you read it for me?
Copy and complete. Two polygons are similar if corresponding angles are blank and corresponding side lengths are blank. Okay. Corresponding angles are congruent and corresponding side lengths are proportional.
Okay, good. And now 3. I can read this. Okay. List all pairs of congruent angles in number 3.
Angle A. Angle A is congruent to angle L.
Okay.
Let me say that. Angle C is congruent to angle N.
Okay.
And angle B is congruent to angle M.
Correct. Now these happen to be oriented the same, but that's not always going to be the case. In other words, if I took this and flipped it...
What I was doing is I was reading... Yeah, you know.
Yeah, the best way to determine it is by the order of the lettering. In other words, you can determine which angles are congruent. We know A is with L because they're the first
letter. Which are corresponding?
What's that?
You mean you can determine which are corresponding?
Yes. In other words, it's not always clear by looking at it. Let me give you an example. What if I had this?
Oh, I know.
If I had this and I had the same thing, only I flipped it.
Yeah.
Now, it's hard for me to tell which angles are congruent. If I say that's ABC and this is XYZ, well, from the picture, I don't know if A is congruent to X or is it congruent to Z. Can't tell. So it would depend on how they labeled it. In other words, this, if they're going to say that triangle ABC is congruent or similar, excuse me. Been working with congruency so much. If it's similar to triangle ZYX, Now that tells me which angles are congruent. A is congruent to Z. You see why?
Mm-hmm.
Okay. Normally you can tell by looking at them. In other words, even if it's a different shape other than a triangle. Although I'm not convinced you can actually tell here. This looks very close to an isosceles triangle, or close to an isosceles triangle, which means that C theoretically could be congruent to M, but not based on the way they've named them. We know that A goes with L, B goes with M, and C goes with N. And that's all you need. You don't even need to look at the picture. You just need to look at that. So, and you have to do everyone 4 also?
What? Yeah.
Okay. Hold on a second. Let me read this full directions. Then write the ratios of the corresponding sides in a statement of proportionality. So,
I already did.
3, what would that be?
AB is similar to LM, BC is similar to MN, and AC is similar to LN.
Okay, I think what they're looking for in terms of an answer is this. AB is to LM as CB is to NM as AC is to LN. That is the ratio of corresponding sides in a statement of proportionality. Exactly what I wrote. Okay? And that's just this corresponding side divided by this corresponding side is the same ratio no matter which corresponding side you're talking about. Okay? Okay. Now let's look at number 4. Which angles are congruent?
Angle D is congruent to angle P, angle E is congruent to angle Q, angle F is congruent to angle R, and angle G is congruent to angle S.
Okay. And again, you could get that from this. In other words, immediately when I look at this, I see 2 right angles. There's 2 right angles down here. So the immediate problem is to figure out whether D is congruent to P or is D congruent to Q. And you can always tell by the way it's labeled. In other words, D has to be congruent to P based on this. And then E goes with Q. So now give me the ratio of corresponding sides in a statement of proportionality.
DE is to PQ, as EF is to QR, as FG is to RS, as GD is to SP.
You got it. There's a 4th one there. RS. Now you got to be careful to make sure that you stay in the denominator and the numerator. So that's the 4th one there. All right. I can make out number 5 enough, I believe. Again, it's not really necessary. At some point, you're going to be forced to figure out which angles are congruent by looking at the figures.
Oh yeah, I can.
But as long as they make it easy for you by labeling it, we know H has to be congruent to W, right?
Oh no, I already know how to put those things.
Okay, cool. And so I know you know the corresponding sides also. At least I think you do.
Yeah.
Give me one set of corresponding sides.
Sides HL and WZ.
So that must be W at the bottom, and V must be off the page here.
Yeah, yeah. Or here's another one. XY JK.
Okay. Yeah, and if they're not labeling it perfectly for you, then what I usually do is, well, that's the shortest side, right? JK is the shortest side of that polygon, which means it's the corresponding side to the shortest side of this polygon. And that's why XY goes with KJ. Again, don't forget that KJ is to KL, that ratio is the same as XY is to VY. In other words, the ratios within the figures are the same as the same two corresponding sides here. It's not just the ratios between the figures, but within the figures, which is a wonderful thing, but I think that that confuses a lot of people. All right, what next? 6?
Mm-hmm.
All right.
6 is a multiple choice. Triangles ABC and DEF are similar. Which statement is not correct? BC over EF equals AC over DF. That's correct. AB over DE equals CA over FD. That's also correct.
Okay.
What?
You know, that's correct. Yeah.
Yeah. COA over FD equals BC over EF. That's correct. So it has to be D by cross elimination.
Okay.
AB over AB over EF now.
Okay, which is not going to be the same as BC over DE.
Yeah.
And I assume you did that with just the letters, right? In other words, when you looked at the first one, it was BC over EF. Well, that's the second and third letter divided by the second and third letter. And then has to be the same as AC, the first and third letter, divided by DF, the first and third letter. So to me, that's the easiest way to do all of these problems, as long as they're going to name them properly for you. Unfortunately, when you are taking your tests like the SAT test, they don't usually name the things. They show you a picture and they tell you, okay, these two triangles are similar, what angles are the same and what sides are the same.
That's still easy. You can do that right now.
Yeah, it is. It's just harder if they're not oriented quite the same. In other words, if we look at number 8, it's been reversed a little bit. The second figure is flipped, so it's not quite as.
But I still know that C is corresponding to T, D is corresponding to U, and E is corresponding to V.
Right, because they've labeled it. Yeah.
Well, no, even without the congruency signs, I can see that.
True. That's true. I know you can. Yep. Okay, so let's see. What are they asking for here? Determine if the polygons are similar and find the scale factor. So for number 7, are they similar?
How
do you tell?
By if all the angles are congruent, right?
No?
No.
Yeah, I'm sorry. I said that when we first started, and that's not correct. All angles, that's only for triangles. If you have two triangles and all three angles are the same, it's always similar. But once you go beyond triangles, like when you're looking at quadrilaterals, like number 7, then having all 4 angles be 90 degrees does not make them similar, because I could have 2 different shaped rectangles. And obviously, 2 random rectangles aren't going to be similar, but they would have all the same 4 angles. How do we figure out if these two figures are similar?
Well, if we turn that smaller one on its side, it is similar. Because 32 times 2 equals 64, and 24 times 2 equals 48.
So what's the scale factor?
It's 2.
2 to 1, exactly.
Scale factor is 2, right? Or 2 over 1.
I prefer 2 to 1. Either one is correct, and 1 to 2 is also correct. Some teachers, and Yansak's one of them, that prefers the numbers be less than 1, which I personally hate. I think whenever you're talking about a scale factor, you should always make big to small. You want to be dealing with not fractions, but whole numbers. And as you go further in geometry, and you go from one...
Mr. Yansak doesn't want it. Mr. Yansak wants it in fractions, too.
Well,
whole numbers.
There's a problem when you go from linear to square to volume, and you're trying to figure out how they're all related. It's much easier to do if the numbers are greater than 1, not less than 1. And if you do little to big, you're always going to end up with a scale factor that's between 0 and 1. Whereas if you do big to little, you'll always end up with a scale factor that's greater than 1. And to me, you're always better off with numbers bigger than 1 rather than fractions, especially when you have to do things like square them or cube them or take the cube root. Let's say, just for an example, what's the cube root of 1/8?
The cube root? Cube root of 1/8 is 1/2.
Correct, but not so easy, was it?
No.
Whereas if I said, what's the cube root of 8? You instantly know that's 2. So it's easier working with 8 than it is 1/8. Whenever you have to take roots, you're better off with whole numbers rather than fractions. And so whenever I do these similarity problems and scale factors, I always do big to little. But I had a student last year that was honors geometry with Yansak, and she was always doing little to big. So either one is correct. It's just a question of which one is more likely to produce errors. So number 7, are they similar?
What? Yes.
Okay. And the scale factor was 2 to 1. About number 8.
They're similar because they're triangles and all the corresponding sides are congruent. Angles are congruent.
Yeah, so now all we got to figure out is the scale factor.
And since we already know, well, the scale factor is 5 over 4, right?
They're similar because they have 3 angles that are the same, and that's enough with triangles. Yeah. So what else is true? In other words, now how do we get the scale factor?
Well, I can automatically take, I could either do 10 over 8, which simplifies down to 5 over 4, but it's easier to just take the 5 over 4.
Yeah, and it's really easy to figure out what the shortest side of this is and the shortest side of that. So those have to be the 2 corresponding sides.
And since you can't simplify that down anymore?
Yeah, I would just say 5 to 4.
Yeah.
Okay.
Unless you want to say 2.5 to 2, which is dumb.
Right. No, 5 to 4. You're better off leaving it in whole numbers. Okay, let's see what else we got here. In the diagram, must mean these 2 figures here. Yeah. Find the scale factor.
Okay, 20 over 8, which can be divisible to 10 over 4, which can be divisible to 5 over 2.
Okay. So to find the corresponding side, you just took the first 2 letters divided by the first 2 letters of this one? that what you did?
Mm-hmm.
Yeah, I like that. Because, first of all, I can't even see this figure. So it's going to be hard for me to look at the two figures and figure out whether they're similar and how they're similar and which are the corresponding sides. So the best way for me to do it is to take those first two letters and compare them with those two letters, and those are the corresponding sides. So you did that, so you get 28, which is 5 to 2. Is that what you came up with?
Yep.
All right. So we got our scale factor. Now we need to find x, y, and z.
Give me a second.
I can't even see which is x.
X is KL basically. You see the K at the bottom?
Yeah,
It's
okay.
it's
I got
it across.
Okay.
And since we know that GF is 11 and that corresponds, or FG, sorry, we can use the scale factor since we know that the 11 is the 2, so just divide 11 by 2 and get 5.5, and then do 5 times 5.5.
Okay.
Getting you 27.5.
Correct. Okay, so that's x. How do we get y?
Give me a second to write that down. Y is corresponding to 30. So let's divide 30 by 5 and we get 6. So 2 times 6 is 12. So y has to be 12.
Okay.
What I'm doing this is how I do this. This is mental math, but I know x is already taken, but I just assign the ratio to a random variable, and I just solve for that variable, and that's the answer.
Yeah, no,
and
for sure. That's what you want to do. You want to go 5 halves,
variable, and then I multiply the
times some random variable equals 30.
Yeah, and then there is
solve that
z.
equation.
There is z, and j corresponds with that. There's angle E, or could also be called z, and angle j corresponds to that, and angle j is 65 degrees. So divide that by 5, you get 13, right?
Correct.
13. So 2 times 13 equals 26.
What are we solving for? Z?
Yeah.
Z is just 65. It's the same angle as J.
You're right.
The angles do not share that scale factor.
I forgot. That was a trick question.
The sides have the scale factor, but the angles are always the same. Now, what's true about the perimeter? The perimeter of the bigger quad is going to be how much bigger than the perimeter of the smaller quad?
5 to 2, same scale rate.
Exactly, because they're both linear measurements.
That's actually a theorem.
It is. Now answer me one last thing. What's true about the area of the bigger one compared to the area of the smaller one?
It's the ratio, right?
It's not 5 to 2. It's the square of the ratio. It's 25 to 4. Let's go over that real quick. If I have a circle that has a radius of 2, I have a bigger circle that has a radius of 4, what's the scale factor between these two similar figures?
The scale factor is 2 over 1, right?
What's the area of the smaller
one? That equals 1, right?
Pi r squared, right?
Mm-hmm.
That's 4 pi. What's the area of the bigger one?
8 pi.
Pi r squared, 16 pi. Notice that the area ratios are 4 to 1. The scale factor is 2 to 1. But the moment I go from a linear factor to an area factor, you square the scale factor. And in fact, if I had a sphere that had a radius of 4 and I was talking volume, the volume is the scale factor cubed. In other words,
I forget all my
if I had a marble, if I had two marbles, one had a radius of 4, the other had a radius of 2. Well, what's the volume of the smaller marble? It's 4/3 pi r squared, 4/3 pi r cubed. So it's 4/3 pi times 8. And this one over here is 4/3 pi times 64. So this one is 8 times the volume of this one. Even though the scale factor is 2 to 1, the volume factor is the scale factor cubed. And this is the reason I like using big to little, is because if you use little to big, you end up with a scale factor of 1 to 2, and then that becomes 1 to 4 when you're looking at area, and then it becomes 1 to 8 when you're looking at volumes. But you haven't quite gotten to that part of geometry yet, but certainly ready for it. I still feel like you're not really being challenged enough on these, but you will, I think.
Well, to be fair, the last time I learned about the pi r squared stuff, the last time we ever went over that was in 7th grade.
Yeah. Well, you'll get into circles. You haven't really gotten into circles yet in your geometry class.
We haven't even learned about cosines.
Trig yet. Yeah, they'll wait until near the end of the semester to introduce you to trig also. You haven't had any trig at all yet, have you? Did you ever get it in Algebra 1?
Nope.
Right. I think the place they introduce it to people is in geometry. So you'll definitely get trig, especially with honors geometry.
Yeah, some of my friends who took geometry last year learned it at the beginning of the year.
Oh, okay. Yeah, they're just going to give you very beginning trig in geometry class. And then you'll get a little bit more trig in Algebra 2 next year. And then you'll get,
I'm going to get all the trig in 2 years.
Full trig class the year following that. So trig, they kind of introduce you a little bit each year until you take the full class. Trig's fun. I think trig is one of the more interesting subjects. All right, let's see. You need to do 12 also? Is that part of your homework?
What? Yeah.
Okay. So two similar for-sale signs have a scale factor of 5 to 3. The larger sign's perimeter is 60. Find the small sign's perimeter.
36.
Okay. Give me the equation you set up. 5 is 3.
So
what?
5x equals 60. 5x equals 60. Because that's larger. And then I divided by 5 and got 12. And 3 times 12 equals 60.
Okay.
That's 36.
Yeah. The way I would have actually done it is 5 is to 3 as 60 is to x. In other words, that's the statement of proportionality in case they want you to write it.
Well, the cross multiplication, that actually takes a little bit longer because that's not just mental math.
I agree. No, I'm totally with you. I don't have any problem with the way you did it. You did it just fine. But there was an earlier question here where they wanted us to list the statement of proportionality up here on number 3, 4, and 5?
Mm-hmm.
Well, if you have to write a statement of proportionality, it's what I have circled. If you have to write just an equation that's true, it's what you gave me. Okay, notice I can take what you gave me and divide both sides by x to get the statement of proportionality.
Mm-hmm.
But you're right. This way does not involve two steps. The bottom one, I got to cross multiply and then divide both sides by 5. Whereas the top one, I can just multiply both sides by, I don't even have to do it the way you did it. The way you did it was actually a little inefficient. You really want to multiply both sides by the reciprocal. Rather than multiplying both sides by 3 and then dividing by 5, just do it all in one step. Whenever you have a fraction as a multiplier and you're trying to get rid of the fraction, you always can get rid of it by multiplying by the reciprocal as long as you do both sides. And
okay, now we're doing 19 through 26.
What's the next one?
19 through 26, which should be on the next page.
Okay.
Next attachment I sent you.
Yeah. All right.
And then that's it, basically.
All right. Hold on. So that was the top one. (19 through 26). All right. The black.
I have that picture a little bit better.
Yeah, it did. Came out a lot better, actually. You know why? Because the book was flat.
Why?
The page was flat. Whereas when you took the picture of the other one, it was bent over, so the side of that page is curved. You can kind of see it here.
Well, actually, to be honest, the page was propped up against something.
Oh, okay.
And I just set my iPad down and propped it up. And then it was somehow facing the correct angle.
Okay. So let's look at 19. The black triangles are similar. Identify the type of special segment shown in blue and find the value of the variable. So the segment shown in blue is what? What's that called?
Look.
Yeah, the blue.
That's called the altitude.
That's the altitude, exactly. Both of them are altitudes. Altitudes being from a vertex perpendicularly to the opposite side. That's all an altitude is.
Mm-hmm.
Okay. Now, because we know they're similar, which sides are similar? What are the See, here's a case where it's not totally clear what the corresponding sides are. Is 18 and 27 corresponding, or is 18 corresponding with the side opposite 27?
Well, because we didn't even need to be told that the lines were parallel, we can by the parallel lines perpendicular to a transversal theorem.
Right.
But we know that we already know the vertical angles are congruent.
Right. And you know this angle is congruent to that angle, and that angle is congruent to that angle. So yeah, you can definitely figure out that all three angles.
Corresponding to 27. 18 is corresponding to 27.
Correct. And one way you know that is because they didn't label this side. Okay? In other words, just because all three angles are the same doesn't necessarily mean that that's the corresponding side to 27. It so happens that whenever you have this kind of a figure, that is the truth, that the corresponding sides are the straight line. So what's the similarity ratio or scale factor, excuse me.
So, wouldn't it be 3 to 2?
Okay. And what's
That's
x going to be?
what?
How do you figure x?
24.
In other words, 3 halves times 16. Okay. Now let's look at 20. Let's see, did we answer everything? Yeah.
Yeah.
Okay, let's look at 20. What's the blue line in 20?
The blue line in 20. It's a median, right?
Yes, because it goes from the vertex to the middle of the opposite side.
Yeah.
And it's not bisecting that angle, even though it looks like those two angles are the same, but that's not what a median does. It does not bisect that angle. It bisects the side that it's connected to. So what's the scale factor?
So
this one's a little harder, huh? To figure out the scale factor. They don't give us two corresponding sides. So how can we figure out the scale factor?
okay. It's 9 over 8, I think.
Well, give me
I know.
give me a ratio or an equation that I can solve. I mean, I know you like to do mental math, so do I, but when they get more complicated,
18,
okay.
18 over y is certainly harder because they don't give you solid numbers.
Right. Now, is 18 and y, are those corresponding?
Yes.
They are, because why? Why are they?
Because the two triangles are similar, because that third angle has to be congruent due to the vertical angle's congruence theorem.
Well,
and because
the simple answer is that y is opposite this angle that's got the double curved line, and 18 is opposite the same angle in the bigger triangle. That makes them correspondent. And notice this is not the same situation as we had over here. The corresponding side over here was 27 as to 18. Those are the two corresponding sides. Whereas in this picture, the corresponding sides are 18 and y. So 18 is to y as what?
I don't know, 16 is to y minus 1?
Uh-huh. In other words, that 16 is corresponding to that median. This median is corresponding to that median. And now we have something that we can put in an equation and solve for y. So help me solve it.
18y minus 18 equals 16y. Subtract 16y. 2y minus 18 equals 0, but you can't do anything with that. You have to add 18. 2y equals 18 divided by 2. Y equals 9.
Okay. And you're right, that was a little trickier. But as long as there's only one variable, we can do it. Had they called this x instead of y minus 1, we could not have solved for anything.
So the ratio is 2 to 1.
Yes. In other words, if y is 9, yeah, 18 is to 9 is 2 to 1. And y minus 1 is 8. So 16 is to 8 is also 2 to 1. All right.
Yeah.
All right. Let's draw a picture on the next one. 21. You've already drawn the picture. I don't need to draw it. Let me look at your picture here.
I didn't draw that.
Oh, you didn't draw that?
You're just the last jerk who had the textbook and doesn't know how to respect property.
NPQ and RST are
But
simple.
I'm not letting people draw on their textbooks. Like, you have scratch paper for a reason.
Yeah, I know. I'm as guilty as a lot of people are, though. I tend to write in the textbook also, but only because I'm lazy.
I don't, because I prefer to show, well, I have to do it in my scratch paper.
I don't blame you. But if you have a really, really complicated figure that's hard to recreate, you know some of those problems where they give you that figure and they ask you for 12 different angles? One of those problems?
Oh, yeah.
Those problems is really beneficial to write in the book because it's hard to recreate the figure on your own. And it's only by
a lot of times,
some of the angles that allow you to answer the other angles.
The only times Mr. Yansak gives us angle puzzles are when they're in, like, packets.
Which are allowed to write in, yeah, okay.
Yeah.
Okay. So let's have a look at this problem.
What?
I'm saying let's have a look at this problem. So which... Okay.
I'm going to write all the given down because...
Well, let's look at those two triangles that somebody drew in there. What's the scale factor? Which triangle is bigger?
What?
Not according to the drawing, but according to the information they're giving us, which triangle is bigger, RST or NPQ?
RST.
Correct. What's the scale factor?
It's 4 over 3. 4 over 3.
Correct, because we know the shortest side on that one is 6, shortest side on this one is 8. Those have to be the two corresponding sides if the figures are similar. That's one thing you can always be certain of, is that even if you have a 6-sided figure that's similar to another 6-sided figure, if there's one side that's clearly the shortest or the longest side, then you immediately know what the corresponding sides are. So this picture actually is quite helpful. So what is RS, what is labeled X here, going to be? What is the question 21 says, find the lengths of the other two sides of RST. So we know RT is 8. What's RS?
Wait. We don't know we don't know which one is 8. It just says the shortest side.
But notice that RT well, it doesn't matter. In other words, they've told us that these two triangles are similar, and they've told us that this one's shortest side is 6, this one's shortest side is 8, therefore the scale factor is 4 to 3. So if this side over here is 10, what is this side?
Well, I get you here, but so 10 divided by 3 is 3 and a third. So 4 times 3 and a third would equal 13 1/3, right?
Why don't you do it the easy way, which is 4/3 times 10. In other words, we're taking our scale factor and multiply it by the shorter or the smaller triangle's equivalent corresponding side. So 40/3 is X. What's labeled?
I know, but I know, but it's just I know that it's 13 and 1/3.
Well, again, ratios are preferable to both proper fractions and decimals. My favorite answer here is that, 40 divided by 3. It's not 13 and a third. It's not 13.3333 because the ratio is precise. Can't be simplified, and it's precise. 40 divided by 3 is more accurate than that. It's the same as if I put a line over that. Now they're the same number. But a lot of times you can write it as a fraction or a ratio, and it's not easy to write it as a decimal. So
You're right.
and you're going to find that when you get to trig is all about ratios. It's not about numbers. It's about ratios of one side of the triangle to another. So you end up with lots of answers that look like that. You would never end up with an answer in trig that was 13 and a third, because that's not a ratio.
Because ratios were always the one thing in algebra I just sucked at.
Well, there's no reason for you to suck at it. Your math skills are way beyond ratios. So now let's find TS. And let's do it the most direct way.
Okay, 36 divided by 3 then.
Well, hold on. We're
going to end up being 12.
4 thirds times 8, right?
32 divided by 3.
Right. And that's the answer. One step. So all we're doing is multiplying the smaller triangles, middle side, by the bigger triangles, scale factor of 4 thirds. That's all you're ever doing when you're doing these. And the corresponding altitude. If this altitude on the smaller triangle is 4.8, what's the altitude on the bigger triangle?
Wait.
Right?
Wait, what?
In other words,
4.8.
Well, it's 4 thirds. I don't really care what the answer is. What I care about is that you're doing it properly. In other words, you're taking the altitude.
4 times 4.8.
You're taking the altitude of the smaller triangle and multiplying it by the scale factor to get the altitude of the bigger triangle.
Yeah. It's 19.2 divided by 3.
Right. And that actually can be simplified into 6.4. So make sure you do simplify them when they can be simplified.
Oh, I know. I did that.
Okay, cool.
The 23.
Whereas this one, I can't, it's not worth simplifying that one into a repeating decimal. Whereas this one simplifies into a nice, perfect two-digit number, 6.4.
Just a heads up, it's 5 right now.
Oh, you're right. Sorry. Thank you for reminding me. Bolton, I will talk to you next week.
No, I'm not trying.
I will talk to you next week, and I'll talk to your brother in a second here.
Okay, bye.